Well, welcome back to the flipped classroom. Our topic tonight is inverse trig. So let's start by copying the sine of 30 equals 1/2. And one of the most important things we want to get out of tonight is just reading this correctly. So we want you to copy this down in words right underneath this example. The sine of 30 equals 1/2. And that key word we want you to underline is of. It's not sine times 30, it's not sine 30, it's the sine of 30. And one way to stress that to yourself is to always put parentheses around what you're saying of. So we really should have the sine of, open the parentheses, 30 equals 1/2. So let's get used to saying it correctly. Next example, cosine, and again I'm going to say of, so put your parentheses in, of 30 equals radical 3/2. So I just want to stress that word of again. Now, another important note before we get started. We want to be very clear, and let's box this in here, that this represents the angle. And this side over here represents the value. Okay, you'll notice that this value is from our table. And this angle here should be a degrees or a radians, 30 degrees, pi/6, a degree or a radian. But you should always be taking the sine or cosine or tangent of an angle, okay, and it's equal to the value. So if I said the tangent of pi/6 equals radical 3/3. So I just want to be clear again. Pi/6, and let's just box it and underline it, represents the angle. Radical 3/3 represents the value. Now, can we convert pi/6 to degrees? Sure. Well, pi/6 is the angle in radians. And if you remember, when you see that 6, think how many degrees? That's actually 30 degrees. Okay, but either way, this represents the angle. And the value, either way, is radical 3/3. Okay, so you'll recall the word inverse. We used it earlier in the year. We said something like switch the x and y and solve for y. Or we even used a different notation. So I just want to recall, if you have a function f of x, and you want to find its inverse, the notation we would use is f inverse to that -1 of x. Now, trig is going to use that same notation, this -1 notation for inverse. For example, if I said sine of x, its inverse looks like this. And here's how you say it. Sine inverse of x. And notice I'm using that word of again when I'm taking the sine of. Sine, here's the word inverse of x. Now, of course, each trig function has its own inverse. So if I said cos x, its inverse would be cosine inverse of x. And tangent obviously works the same way. Now, you've seen all these on our calculator before. I just want to make a note. They are all on the same button. You'll just have to hit second. So if you look on the sine button, you'll see sine inverse on the same button. You'll just have to hit second sine, or second cosine, or second tan. All right, title this section, Writing Equivalent Equations. So example 1, you're given, and practice reading it, cosine of A equals 5/6. So let's just be clear. This is the angle again. This is the value. So what are you trying to find, the angle or the value? Well, I would say we're definitely trying to find the angle. And in order to find the angle, so let's just make a note here, we're just going to take the inverse of both sides. And we're not going to be sloppy, we're going to write it out. Don't go to your calculator, like I said, we're just going to write it out. So I'm going to say cos inverse of this side, which is the cosine of A, equals cos inverse of this side, which is 5/6. So again, no shortcuts, take the cos inverse of both sides. Now here's the deal. Any function and its inverse zap each other out. So all that's left on this side is A equals cos inverse of 5/6. And all we're doing, like I said, is writing equivalent expressions. This is how I would solve the angle, cos inverse of 5/6. Let's try another one. Example 2. Sine theta equals radical 3/2. Now you might be thinking you know what the answer is, but I'm not asking for the answer. I just want you to solve for theta. Okay, so again, to get this angle by itself, I need to get rid of the word in front of it. It says the sine of theta. Now, I just want to be clear. I can't just divide sine over because it's not sine times theta. It's sine of theta. That's why I can't divide by sine. So all we're going to do is take the inverse of both sides. This time I see sine, so I'm using sine inverse. So no shortcuts, write it out. Sine inverse of sine theta equals sine inverse of radical 3 over 2. Sine inverse and sine that. Theta equals sine inverse of radical 3 over 2. All right, example 3. Tan theta equals 3/4. You got this one on your own. Pause it, see if we get the same answer. Quick check. All I did, no shortcuts, wrote tan inverse in front of both sides. Those zapped out, and theta equals tan inverse of 3/4. All right, now I'm going to write it the opposite way. Sine inverse of 3/5 equals A. Now, I don't want to take the sine inverse because guess what? I already see sine inverse. So the opposite of sine inverse would be just to take the sine of both sides. Remember, any function and its inverse undo each other. So I'm going to say take the sine of this side, which is sine inverse of 3/5, equals, balance it out, do the exact same thing, the sine of A. And again, this trig function and its inverse zap out, and I get 3/5 equals sine of A. So I just want to be clear, you're always doing the opposite. If you see the inverse, do the regular sign. If you see the regular sign, do the inverse. All right, you've got this one on your own. Pause it and see if you get the same thing. Cos inverse equals 2/5. Cos inverse of 2/5 equals theta. Go ahead and rewrite this. So I already had cos inverse, so I took cosine of both sides. Those will zap out, and I'll have 2/5 equals the cosine of theta. Now, in trig, there's another name for inverse. Okay, so instead of saying inverse in trig, sometimes they like to use the word arc. Now, they mean the same thing. For example, sine inverse of x is equivalent to saying arc sine of x. Both of these things are saying find the inverse. It's just another way to say the exact same thing. Cosine inverse of x is the same as saying arc cosine of x. And tan inverse, you've probably guessed it, is the same thing as saying arc tan of x. Okay, they both mean inverse. So let's be really clear, both are inverses. Just two ways to say the same thing. All right, so here's a common question. Find the value of, and I'll list the following out here, given a domain 0 is less than or equal to theta is less than or equal to 90 degrees. So this is telling me my answer has to fall between 0 and 90 degrees. Now, find arc sine of radical 3 over 2. So I just want you to box this in here, or bracket it in, and I want you to say, is that the angle measure, or is that the value? Is it an angle measure like 30 degrees, 60 degrees, 45, or is it a value from the table? So hopefully you're saying, this is a value. And the question is, when you see arc sine, the question is, what is the angle? So you can kind of think of arc as angle. They're asking, what is the angle when you see this? So this is something you should know right from your table of values. So I want you to picture the table of values in your head. Close your eyes if you have to. You are looking for sine, and you're looking for radical 3 over 2. What is the angle? Who gives that to you? Hopefully you're saying 60 degrees. Sine of 60 equals radical 3 over 2. And now box that in. That's actually the answer they're looking for. Who is the angle that gives you 60 degrees? That gives you radical 3 over 2, and you're thinking 60 degrees. Now let's do a quick check. Does that fall between your domain of 0 to 90? Well, 60 surely falls in there. When if they said your angle has to fall between 0 and pi over 2. All right, well, let's think about this. I'm going to quickly change pi over 2 to degrees so I know what they're talking about there. So I'm going to do 180 over pi, kill my pi's, 180 divided by 2 is 90. So they're really saying the same thing, except this time they want your answer in radians. So can you do that without the formula? Do you know 60 degrees in radians? That's definitely one we should know. I would say that answer is pi over 3. So these two answers mean the same thing. One is in degrees and one is in radians. And we're going to answer every question that way tonight. One in degrees and one in radians. Let's try another. Arctan of radical 3 over 3. So again, I just want to talk through what the question's even asking. This is the value. Arc means find the angle. Alright, so let's first give our answer in degrees. Picture your table, close your eyes, picture your table. You're picturing tangent, you're picturing radical 3 over 3. What is the angle measure that gives you that value? Hopefully you're saying radical 3 over 3 has all the 3's, so that would be 30 degrees. Okay, now let's put that same answer in radians. And hopefully you don't have to use the formula for these two. If you see 30 degrees, you should actually be thinking pi over 6. All right, question 3. Sine inverse of radical 2 over 2. So again, this is the value from the table. And arc or inverse mean the same thing, so they're asking you for the angle. Arc and inverse mean the same thing. So close your eyes, picture your sine, picture radical 2 over 2. What is the angle measure they're telling you? Hopefully you've guessed it, and that is 45 degrees. Now if I need that in radians, so again, this is in degrees, what is 45 degrees in radians? Well, hopefully you're saying pi over 4. Alright, if you're starting to get the hang of it, the idea is you're just looking for the angle who gives you the answer they have. Now, I'm going to throw a twist in there. Question 4. This time, it says find the value of cos inverse of radical 3 over 2, but watch my domain. This time you have to give me an answer that falls in that domain. Alright, so let's talk through it. This again is the value. Inverse means find the angle. What angle pops in your head when you see cosine and radical 3 over 2? So close your eyes, picture the table. Hopefully you're thinking 30 degrees. But now think about that answer. Does 30 degrees fall between 90 and 180? Gosh, no. So here's what I'm going to do. I'm going to draw this out because I know I have to give an answer between 90 and 180. All right? And I do know the cosine of 30 is radical 3 over 2, so I'm going to draw in my reference triangle. And I'm going to put 30 degrees here. Now, remember, that reference angle just tells me how far I am from the x-axis. But here's my initial side, here's my terminal side. I really want this angle. And how would you get that? Well, just ask yourself, how far is 30 from the x-axis? Or basically 180. How far is 30 from 180? So I'm just taking 180 minus 30, which we've done a million times, getting that reference angle, and I get an angle of 150 degrees. All right, now I'm going to quickly convert that to radians. So I could use that nice little formula, pi over 180. That's certainly doable. Let me throw another trick at you. If you like the pi over 180 formula, that's fine, but if you can pick this up, it's another neat little trick. Basically, how many times does 30 go into 150? Can you think about that? How many times does 30 go into 150? Well, if you kill the zeros, 15 divided by 3 is 5. So I would say it goes in 5 times. And now what's the reference angle for 30? Well, that's pi over 6. So a really easy way to convert is just take your angle 30, divide by that angle, 150, goes in 5 times, and because it's 30, it gets a pi over 6. Let's try another one. Cosine inverse equals 1/2, and we're still going to go with the domain 0 to 180. Okay, so again, this is the value from the table. This is telling you to find the angle. So close your eyes, picture the chart. The cosine of who is 1/2? Hopefully you're saying cosine of 60 degrees. Now you can't stop there again because the domain is 0 to 180. So I'm going to quickly sketch it out. This time I'm making a 60-degree angle in that second quadrant between 90 and 180. I'm saying I need to know this angle, and that means 60 degrees is really my reference angle. So 60 degrees from 180, hopefully you've got it already, and you're thinking 120 degrees. So I'm kind of doing some math in my head. We've done this, for a week straight now. You're just saying how far is 60 from 180. All right, so that's my angle in degrees. If I wanted that in radians, again, I'm going to do the quick method. You could multiply by that pi over 180, but just ask yourself, how many times does 60 go into 120? And hopefully you're saying right off the bat, 2 times. Now, what is 60 degrees in radians? Well, that's actually pi over 3. So it's really just 2 pi over 3. All right, so an even uglier one. Example 3. This time the domain is between -90 and 0 degrees. So let's just stop right there and try to even figure out what quadrant we're in. If this is 0 and you went -90, remember that's implying you went backwards 90. So this is telling me I should be in quadrant 4. So just keep that in mind. Your answer has to be in quadrant 4. All right, arc sine equals -1/2. So remember, this is the value from the table. Arc means find the angle, same as inverse. So close your eyes, picture sine 1/2. Hopefully you're thinking 30 degrees. All right, now we really got to slow down. We've got to put 30 degrees, we just said, in the 4th quadrant. All right, so notice you're not using 180 this time. 180 is on the left-hand side. What number are you using on the right-hand side? Hopefully you've guessed 360 when finding the reference angle. So I'm saying 360 minus 330 gets me, minus just 30. Oh boy. Shucks, I lost my graph. 360 minus 30 should be 330 degrees. Now, this is going to sound crazy, but that's not actually our answer either, because 330 degrees does not fall between -90 and 0. So here's what I'm going to do. I'm going to draw out 330 degrees, which would be from here to here. And I'm going to say, what is a coterminal angle? Do you remember coterminal from earlier in the week? Coterminal angle means they share the same terminal side. It has to land on this line also. So you could go positive 330, or you could go negative 30 degrees. And that answer, in fact, falls within our domain from -90 to 0. So my actual answer here is -30, or if I put that in radians, -30 degrees is pi over 6. All right, let's step it up a little bit. This is the cosine of arc sine of radical 3 over 2. So I'm going to put parentheses around this as well. Now, this is like composition of functions. We're going to work backwards. Okay? If you remember, like f of g of 2, you would start with the inside 2, plug it into g, take that answer and plug it into f. So we're going composition. We're working backwards. We're going to start inside the parentheses. So let's say start here. So I'm just going to rewrite this cosine I have out front, and I basically need to get this answer. So the question is, the value is radical 3 over 2. Arc means find the angle. So you have it already? The sine of who is radical 3 over 2? Hopefully you're saying the sine of 60. So I can replace all this junk here with just 60 degrees. Now the question is really find the cosine of 60. So now picture that table. Cosine of 60 is in fact just 1/2. So it's like a double problem. Start inside, clean it up, and then go get your answer. Let's try another example. The tangent of arc cosine of radical 3 over 2. So this, again, arc means angle or inverse. This is my value. Okay, so rewrite tangent, clean up inside our main parentheses. So think to yourself, the trig function's cosine, the value's radical 3 over 2. How many degrees are you thinking? Cosine of 30. And now the question just says, what is the tangent of 30? Well, radical 3 over 3. All right, example 3. Pause it, try it on your own, see if we get the same thing, and then check with mine. So I'm saying arc cosine, answer, the value is 1/2. The word's cosine, so I'm thinking the cosine of 60 is 1/2. And then my question is really the sine of 60, which is radical 3 over 2. All right, one more example before we move on. Again, pause it, try it on your own, see if you get the same thing. There you go, number 4. So I'm saying the value is 1/2. Arc sine, who do I take the sine of to get 1/2? I say that's the sine of 30. And then the cosine of 30, radical 3 over 2. Have you noticed it's been very convenient that we've always gotten a value we know from the table, like 1/2, radical 3 over 3, radical 3 over 2, radical 2 over 2? What happens if you get a value here that you don't know? For example, I don't know who arctan of 5/12 is. I'm assuming you don't either. But here's how you would attack that problem. Again, you're going to start inside the parentheses. And if you don't know the value, but not one from our table, all we're going to do is sketch it out. All right, so we're going to assume it's in the first quadrant unless they say otherwise. So again, it's one of the bow tie. Make a piece like that. And just say to yourself, tangent is opposite over adjacent, SOHCAHTOA. So theta always sits at the origin, and label your sides. Opposite is 5, adjacent is 12. And I'm going to use Pythagorean theorem to get that missing side. 5 squared plus 12 squared equals c squared. This happens to be an identity, and I know my missing side is 13. So here's the deal. You're just going to use this piece here to sketch out the picture, and then we're done with it. Now the question is, what is the sine of that angle? So basically, all this piece did in here was get me theta, and the question is now, what is the sine of theta? And looking at that picture, I want opposite over hypotenuse, opposite over hypotenuse. I'm going to say the sine is 5 over 13. Let's try another one. All right, the tangent of arc cosine of 5 over 13. So again, I don't know who to take the angle of to get 5 over 13. So I'm going to use this to find theta, and I'm just going to sketch it out. So I'll quickly draw my axes. Again, I'm going to assume I'm in quadrant 1, unless I'm told otherwise. Theta sits at the origin. And this time I'm using cosine, so I'm saying SOHCAHTOA, adjacent over hypotenuse. So 5, 13. And again, it's a triple. Hopefully you know this side is going up, so it's a positive 12. And now I just need to say, okay, they're really asking me for the tangent of theta. All of that turned into theta. And the tangent is opposite over adjacent, so I'm going to say this answer is opposite over adjacent, which is 12 over 5. Find the value of a positive acute angle theta to the nearest minute. So let's underline this word minute and nearest. First of all, they're telling me to round when it says nearest, and minute means I definitely have to use my calculator. This is not something we want you to do in your head. And the question, of course, is sine theta equals 0.0935. So, in order to find theta, remember, read this to yourself. It's the sine of theta. It doesn't say times, so it's not like you can divide sine over. It's the sine of theta. So you have to take the inverse in order to solve for theta. So again, no baby steps, write it out. Sine inverse of sine theta equals sine inverse of 0.0935. Now remember, whoops, those are going to zap each other out. So you're going to get theta equals sine inverse of 0.0935. Now they want this answer to the nearest minute. So you're going to grab your calculator. You're going to type this in. So on your calculator screen, you're hitting second sine 0.0935. And you're going to get some nice answer. And I got 5.364 blah, 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 blah. Now, this is currently in, when you found this angle, this should be in degrees. The question said round to the nearest minute. So at this point, what you want to do on your calculator is you want to, and let's jot this down so we have this in our notebook, you're going to hit that second angle button. Second angle. And in there, you're going to see something that says number 4, DMS. And that arrow there means convert. And DMS stands for degrees, minutes, and seconds. And if you hit enter on that twice, you should see the screen that looks like this. And it'll basically say, I took your answer and converted it to degrees, minutes, and seconds. Now the question said to the nearest minute. So the minutes are there at 21. So remember, keep your degrees. I would say that's 5 degrees, and I'm only rounding the minutes. This is going to round me up to 22 minutes. Okay. Well, I think that covers all we need to know for inverse trig as of today. So I just want to reiterate, sine inverse of x means the same thing as saying arc sine of x. In both instances, you are finding the inverse. And basically what that means is you are finding the angle. So when you take the inverse, the whole key is that you are looking for the angle. Well, we look forward to seeing you tomorrow. Have a great night.